So there's a very interesting question in calculus. So how to find the derivative of like a complex expression like this? Of course, you can use the product and quotient rule to find the derivative, but that won't be very easy because like when you have terms like that. So, but there's like a general technique. So the technique is like what we normally say when you have complex expressions, like when you have complicated expressions like that, what we gonna do with many terms with products and quotients. When you have more products and quotients, we're gonna use what they call the logarithmic differentiation. Logarithmic differentiation. That's like a special technique. So we use this special technique in two main cases. When we have a power of a power, when both of those functions are not constants, we use logarithmic differentiation. And when you have complex expression like this, we use logarithmic differentiation. So let's see the steps. So such a problem normally have like 4 steps. So the first step is we can write the given expression as y equal the expression. We do that to make the calculation simple. So that's why we do the first step. The second step, what we do, we can take natural log of both sides. So we can take the natural log of both sides, and then we're going to simplify the right hand side into sums and differences. So what will happen? This is like a very important step. When you do take the natural log, what will happen? All those products and quotients becomes sums and differences. So that's exactly the reason why we're going to use the log differentiation. So that's like a main step. So all the products and quotients becomes sums and differences. And then the next step is we can use a chain rule to find the derivative. So main formula is this one. So we can you will see that we use this in multiple steps. So what is that? When you take a derivative of a natural log function, what will happen? The function goes down and the derivative goes to the top. So that's like a main formula we use. And then we use that to differentiate both sides. We use this one to differentiate the left and the right. And then finally, you need to multiply both sides by the given function y. So that's the last step. And then normally, like when you get expressions like that, we normally don't simplify this one because these are really complicated. So let's see step by step and see how we're gonna do this problem. So we have y equal x to the sixth and the cube root of x squared plus 1 to the fourth power divided by e to the negative 2x sine 7th power 3x. So it's very complex. So what's gonna happen? We're gonna write this one using powers first. So that's like a interesting second step. So we can write this one as x sixth, and then we can write this one as x squared plus 1 to the fourth power cube root divided by e to the negative 2x. We don't do anything with this one, and then we can write this one as sine 3x to the 7th power. So we can exaggerate all those powers. Now we can recall one of the actually 5 of the logarithmic properties here. So let's recall them. When you have a product, it becomes a sum. When we have a quotient, it becomes a difference. So you can see that the product becomes a sum, quotient becomes a difference. And then the third one is what we normally call the power rule. So what will happen? This power comes out. So power comes out. It's going to be log b base to the x. So all of these are very important. And then we also use two other results. So you know that a natural log e equal 1, we use that. And also we know that natural log 1 equal to 0. So the reason is we know that any power to 0, any number to a 0 power is a 1. That's why the second one is, and then here we can say e to the 1 equal e. So that's the reason. And then the interesting part is the first three valid for any base. So especially when the base equal to e. So when the base equal to e, we know that we can write it like that. So we know that when the log base e x, we normally write this one as ln x. So when the base is e. Okay, so that means this is true for any, so even for ln. Okay, so that's the main result. Now let's see how we're going to use this to solve the problem. We normally learn these results in pre-calculus classes. So if you don't know, this is what you need to remember, these 5 results. So let's go back to the problem. So now what we can do, we're going to go to the, so we did the first step, so go to the second step. What the second step is saying, taking a natural log of both sides. So taking, we normally say taking ln of both sides. So ln means natural log of both sides. So what will happen on the left side, it's going to be ln y on this side. The other side you have ln the complex expression, which is x to the 6th x squared plus 3 to the 4 cube 4 third and e to the negative 2x and then sine 3x to the 7th power. We did a little exaggeration here. Okay, so you can see now all the products become sums because of the previous result. Quotients becomes differences. So because of that, you can write this one as, if you look at the first term, you can write this one as ln x to the 6th. And the next one is also a product. So that means it becomes a plus. So ln x squared plus 3 to the 4 third. Actually, it's not 3, actually it's 5. So let's put that back in. So it's 5 and 5. Okay, so then the first two terms. And then you can see these are in the numerator. Those are quotients. So that means it's going to be negative. So it's going to be negative ln e to the negative 2x. And there's one more quotient. So this quotient also going to be negative. So it's going to be negative ln. We have sine 3x to the 7th power. So we use the product and difference. So product and quotient you turn into pluses and minuses. Next one we can use the power rule. So we can use the third result, but the third result is if there are any powers, those powers gonna come out. So there are powers here come out. And then also we can use one more result here, and then you can see we have ln e. Ln e, we say that ln e equal to 1. So that means this term is gone. So you only get e to the negative 3x. But before that, what will happen? The power gonna comes out. So if power comes out using the third result, this is gonna be 6 ln x. The next one is going to be 4 third ln x squared plus 5. Next one is negative 2x ln e, but we know that ln e equals to 1, so now we can ignore that. And then because 1, and then here what's going to happen is going to be negative 7 comes out ln sine 3x. So you can see that this is very simple compared to what we had earlier. There are no powers, it's just sums and differences. Now we can recall one more result from calculus. So let's recall this result. We know that if you take a derivative of a function, log function, so derivative of the natural log of a absolute value, so it's like a much more. Even without absolute value, this is true. So even with absolute value, what happened? The function goes down, the derivative goes to the top. So this is the major result we use in these calculations. This is one of the major results we use. So this is also true without absolute sign. Okay. So true, also true without the absolute value sign. So now let's try to use that result. So what we're gonna use this result. Now what we can do, we're gonna take the derivative of the expression. So differentiate with respect to we need with respect to x. But you can see the function is a y function. What we have is ln y is a y function. That means we have to use the chain rule. So different with respect to using the chain rule. And if you are not familiar with the chain rule, so you can look at the main video. and you can find the link in the description. It's very easy once you know it. Like it's not difficult. It's very easy. So what happened on the left side? What happened is by the chain rule, because it's a ln y. What we have is ln y. So ln y becomes 1 over y. Well, that's why it says function goes down, and the derivative you multiply by the derivative of the function. We write it like that, or you can write y prime. And then so we're done with the first term. So let's go to the second term. So in the second term, what happened? So you get 6 times the derivative of ln is 1 over x, and then plus we have 4/3, and then we have the log function. So that means the function goes down, which is x squared plus 5, derivative is 2x. So you've done it the first two. The second one is what we have is 2x. So that means 2x means you're going to get 2. And then finally we have negative 7 ln sine 3x. So that means function goes down. That means sine 3x goes down. And we multiply by the derivative of that. Sine derivative means cosine is the chain rule. No change to the inside function. Multiply by the derivative of the inside function, which is 3. So that's what happened. So, and then what we're going to do now is, if you can, simplify. So here we can write this side is as y prime over y, just to make the calculation simple. This one you can write as 6 over x. Here we can write this one as 8x over 3 times x squared plus 5. And then we have a 2 here. And then what will happen? You know that cosine over sine is cotangent from the trigonometry. And then you multiply numbers, so you're going to get 21 cotangent 3x. So we are not going to simplify this, so we just leave it like that. So the last step is, so what we do, we're going to like do a little bit of simplification, but we are not going to take any common denominator or something like that unless it is really obvious. Now what we're going to do, we're going to multiply both sides by y. So that's the next step. So multiplying both sides by y, so we're going to multiply both sides by y. So we always have this step. So what will happen is you're going to get y prime equal y times that large expression. I'm going to leave it like that. So let's write the large expression now. So what we have is those original expression, which is x to the 6th. We always need to do this step, and then which is 5. We have a 4th power, the cube root, that's the numerator. In the denominator we have e to the negative 2x sine, we have 7 3x, times, we can write this expression, so we say x over 6, and then plus 8x over x squared plus 1 plus 5, and then plus 2, and then minus 21 cotangent 3x. So that is the final answer. We leave this as the final answer. We are not going to simplify. So this is the step. So you can see that it's not that difficult, but there are certain steps that you need to remember. So we use several properties of logarithm, and then we take the derivative of the logarithm, and then we also use the chain rules. There are 3 steps we use. We use the logarithm property, we take the derivative of the log, and then we also use the chain rule in this problem. So we go through 4 steps to do a problem like that. So and then you can look at the main video, the practice problems video, to see more problems like that. So yeah, so this is how we do a problem like that. It's not that difficult, but there are certain steps that you remember. Okay, so thank you for watching.